Welcome, learner, to STEM Pathway, where we focus on building our mathematical skills. Today, we are looking at expressing numbers as a product of its factors or prime factors. Let us first define. A factor. A factor. A factor is a number. That divides a given number without any remainder. So a number that divides a given number without any remainder, that becomes a factor. So they are also called devices. They are also called devices. So that is the name of factors, devices. So you talk about factors, we're talking about devices. E.g. lists the factors for 24. In short, you ask, find numbers that can divide 24 without a remainder. So we have 24 as a number, solution. The first number that can divide 24 without a remainder is 1. We have 2. We have 3. We have 4. We have 6. We have 8. We have 12. And we have 24 as itself. So that tells you factors cannot be bigger than the number. But the number is also one among the factors that divides the number. So 24 divides itself. So 24 goes in 24 one times, and 1 goes in 24 times. So 24 is a factor of 24. But a number like 1248 is not a factor of 24 because we are looking at the number 24. So we know about factors. In this case, we are talking about divisors, and now that can divide a given number without any remainder. So all these divide 24 without any remainder. So you can be told to give the factors of any number. For example, we have done number 1. Let us do number 2. Let us have least factors of 121. So we have 1 can go into 121 times. We have 11 and we have 121. Those are the factors of the number 121. Then another example, example 3, the last example, 2, 5, 6, a bigger number. So this can have multiples of divisors or factors. We can have 2, can have here, we have done the utility test of numbers. 2 plus 5 is 7, plus 6, that is 13. It is not divisible by 3. We can do the utility test for 4. So 4, we said you look at the 2 last digits, so 56. So yes, this is an even number, but is it a multiple of 4? Yes, it is a multiple of 4. For this is 4, this is 14. 4 goes here 14 times, so we have 4. Because 4 goes into 5 1 times, remainder 1, 16 4 times. Then you also have 8. Because 8 goes into 25 3 times, 24, 16 2 times. We can also have 16. Maybe we also can add to 56, 28. So the list is long. To 56. These are numbers that divide that number without any remainder. So you can now have many multiples there. We can even have 128 is still a multiple of 256, but our list is just a few. So when we talk about factors, these are the factors which can divide this number without any remainder. Now let us try and focus on prime factors. Prime factors. Prime factors, let us define them, are prime numbers that divides a given number without any remainder. So you may be told express a number in its prime factors, or you may be told express a number in its factors. So we talk about prime factors, we talk about prime numbers. And we say numbers with only two divisors, numbers with only two divisors. In short, two factors. That is one as a number and the number itself. And the number itself. The number itself. And the number itself. So we can look at several examples on expressing numbers as a product of its factors or prime factors. So let us look at the first example. We have, let me say, 84. So express 84 in express 84 as a product of its factors. So if at all express a given number as a product of its factors, this is not very specific. So you can have even numbers, odd numbers, prime numbers. But when it is express the number as a product of its prime factors, then you are specific about prime numbers. So we have solution. Here we use what is called tree format. So we start with 84. So this is a number divided by 2. 2 goes there, 42. Again 2, 21. 2 plus 1 is 3, so we go to 3. That is 7. So 84 is written as, in its factors, it is written as 2 times 2 times 3 times 7. So this is the answer. You have expressed it in the form of its factors. Yes, you could proceed here and find 7 goes there 1. But there's no need of repetition because you're only going to take again times 1, and now times 1 is just the number, so there's no need of writing that one. Then we go to example 2. Now let me say the 256 that we had. We express it in the form of, you express it as a product of its factors. We are not been yet told prime factors. So we again start here 2 because of 6 an even number. This is 1, 2, 8. 2, this is 6, 4. 2, this is 3, 2. 2, this is 1, 6. 2, that is 8. 2, that is 4. 2, that is 2, 2. So this is written as 256 can be written in its factors product of its factors as 2. Just count this 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. In which some cases you may be seeing these are 8, 2. So 2 raised power 8. That is now in power form. But we are told to express it in the product. So you put the right one. The right one is this one here. So let us proceed and look at another example before we end, and we look at other example. This is a very essential topic. It lays for us the foundation of doing the GCDs and the LCMs. It lays for us the foundation of doing the GCDs and the LCM. Now let us look at the examples on prime factors. Express, let me get a number 1416, express 1416 as a product of its prime factor. So this is very specific. So I talk about prime numbers. And you know that 2 is the only even number that is a prime number, since it has only two divisors, that is 1 and 2 is solved. So allow me to have this. So let us solve this. So we express it. So we have 14, 1, 6. You check at the ones place value there is 6, so we start with the 2. So this is 7, 0, 8, 2, 3, 5, 4, 2. This is 1, 6, 7. This is 7. Sorry, 7, 7. Then if you try look for any other number that you can multiply to give us 27, you just try the receive test. 1 plus 7 is 8. 8 plus 7 is 15. So this number is divisible by 3. So this is giving you 5. Remainder. That will be going giving you 5, 27. That is 9 times. Then again ask yourself, 5 and 9, is there any number that gives us that can go to 59? There is none. Therefore, we express this as 2 times 2 times 2 times 3 times 59. We have expressed that number 14, 16 as product of its prime factors. Product of its prime factors. Let us try this. Let me give this one. This is example 1. You'll be told in example 2, express 1728, express 1728 and 2025 in their product of its prime factor, and evaluate. Allow me get a number here, and evaluate 3 cube root of 1728 over square root of 2025. So your first goal, you express this one 1728 and 2025 as a product of their prime factors. Then you evaluate this. So let us do it together, learner. This is very simple. So we'll have solution. We start by expressing 1728 into its prime factor product. So 1728, we start here with 2. 2 goes here. That will be 8. There will be 6, 4, 2, 4, 3, 2. Then here 2. Here will be 2. There will be 1, 6, 2, 1, 0, 8, 2, 5, 4. Then you have that 5, 4. Start with it here again. 2, 2, 7. Now 3, 3, 9. That will be 3, 3. That will be 3, 3. Therefore, this is calculated as, you can write this as the product of this prime factor. You can even now put them in power form. This is 1, 2, 3, 4, 5, 6. So this is 2 raised to power 6 times. This is 1, 2, 3. 3 raised to power 3. That is how you express the 1728 in its prime factor. Then 2025, this here, 5 makes it not divisible by 2, therefore you can go to 3. 2 plus 0 plus 2 plus 5, that is 9, so this is divisible by 3. So this will be, here will be 6, 18, 22, 7, 5. This is 13, 5, 18, again 3. This will be 2, 2, 5. Again 3 because these are 9, 3, 7, 7. Then we have 5. Again 3. This is with 2, 5. Then 5, 5, 5. So this can be written as, this is 3 raised to power 4 times 5 raised to power 2. The powers here indicate the number of times 3 is appearing here. We could also write this as 3 times 3 times 3 times 3 times 5 times 5. It is still okay. Even this could have written 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. So we have those ones. But now we were told to evaluate this. Maybe you have everything because you have written it down. So me have this in mind. So let me write it here. This 17, 28, 17, 28, we have got our part to be 2 raised power 6 times 3 raised power 3. So allow me now this part. So you'll be told to find the cube root of that. So we can start with the cube root of 1728. We can start with the cube root. So we are told to get the cube root of 1728, which is now equal to cube root of 2 raised power 6 times 3 raised power 3. Learn again this. For those already in grade 9, you may understand this. Or those who are in Form 2, you may understand this in terms of indices. But there's no even arm if you understand it in grade 7 or grade 8. So this is the same as cube root of a raised power 3 is the same as a cube root becomes a power third. So this will be a raised power 3 times power third. This over 1 here, here 1, here 1. Answer being a. And therefore, this is to mean we are going to say 2 raised power 6 times raised power third times 3 raised power 3 times raised power third. So this will be given as, this will be 2 raised power 6 times 3 raised power third. Everything here is raised power again what? This raised power 3, then this raised power a third. So cube root becomes a third in the power. Therefore, multiply the power. So this will be 2 raised power 6 times a third times 3 raised power 3 times a third. You multiply the powers. So this will give you 2 raised power 2 because this is over 1. So here 1, there 2. Then here 1, here 1. So times again 3 raised power 1. So the cube root of 1728 is equal to 2 raised power 2 times 3 raised power 1, which is just 3. A number raised power 1 is just a number. Then we come to square root, that is numerator. We come to denominator. We come, which actually this gives us 4 times 3, which gives us 12. Then denominator comes to be square root of 2025, which is square root of, there is our answer, 3 raised power 4, 3 raised power 4 times 5 raised power 2. So square root of a is the same as a and a half power half. So if it was a raised power 2, this will be a raised power 2 times a half, which gives you a. So square root of a number which is squared is the number. So in this case, square root of a raised power 2 is a. So that is to mean square root cancel the squares, because square root is the opposite of square root. And here, cube root is the opposite of what? Third, the power of a third here. So this will cancel this. So it is the opposite of cube. So cube root is the opposite of cube. So cube cancel the cube root. Here, square cancel square root. So that here we'll have 3 raised power 4 times 5 raised power 2, square root yake inakuwa 3 raised power 4 times 5 raised power 2. Everything here is raised a half. So this will be 3 raised power 4 times a half times 5 raised power 2 times a half. Hii inaenda hapo 1, hii mara mbili. This will be 3 raised power 2. Then this one will be giving you 5 raised power 1. Therefore, we say Hebrew square root of 2025 is equal to 3 raised power 2 times 5 raised power 1, which is 9 times 5, giving us 45. And therefore, we bring the numerator 12, denominator 45. You say 3 goes here 4 times, 3 goes here 15. Our answer being 4 over 15. That's how you do it. That's how you do it. I believe it's okay. You can take time. You can even pause and now try to do it again if you get 4 over 15. So you can even look at more example. If there's any question you may have, you may pause and we'll do it for you. God bless you. See you in the next lesson.